I'm Dan Massey, and I'm going to show you how I collected venom from scorpions for a research project. This process of collecting venom is called milking. In this video, I'm milking scorpions in my home. What I have here is a bark scorpion, which until recently was found primarily in Arizona and Mexico. The bark scorpion's venom can cause severe neurotoxic symptoms and in some cases require hospitalization. The only way a scorpion can hurt you is by stinging you with the tip of its tail, called a tailsin, and injecting venom. The scorpion's pinchers are quite weak, so if I use forceps to hold the scorpion by the tail, it can't hurt me. In order to collect scorpion venom for my study, I need the scorpion to express its venom. To do this, I administer a low electrical stimulation. The electricity doesn't hurt the scorpion, but does make it express its venom. To administer the stimulation, I hold the scorpion with a pair of forceps. The forceps have a positive electrical lead attached to them. Another wire, a negative electrical lead, is attached to this T-strainer. When I touch the scorpion to the T-strainer, it completes a circuit and the scorpion receives a low electrical stimulation. Right now there's no stimulation applied to the scorpion, but when I touch it to the T-strainer, it completes a circuit and expresses its venom. Since I do not wish to harm the scorpion with increased electricity, agitating it also helps express venom. As the scorpion is stimulated, you can see the tail pulsate and a tiny drop of venom expressed from the tailsin. I have a capillary tube in my other hand so I can collect the venom as it's being expressed. By the way, the forceps don't hurt the scorpion. Its exoskeleton is very tough. A scorpion releases only a tiny amount of venom at a time. It doesn't need to release more because the venom works so well on its prey. You can see it takes a lot of patience to milk scorpions, and if done in your home, an understanding family. I have more than 100 scorpions in my home, and my wife helped collect them all. We collected the scorpions from a state park in New Mexico where the bark scorpions were previously undocumented. I wanted to obtain their venom so we could study this new population of scorpions and compare it with populations of the same species. To do my research, I had to milk each scorpion twice, 3 weeks apart. After being milked, a scorpion needs around 2 to 3 weeks to regenerate its supply of venom, and a meal or two. It may only take a single sting from a bark scorpion to cause neurotoxic symptoms in a human. To do research on scorpion venom, we needed as much venom as possible to successfully perform experiments. That's why I had to milk more than 100 scorpions, more than once, to get enough venom for the study. Here's another view of a scorpion being milked. See how the tail pulses with the stimulation? And how only a tiny drop of venom comes out? And how I capture the venom with a capillary tube. The most striking results of my research were that the scorpions found in New Mexico were twice as toxic as those from Arizona. And anti-venom reverses the effects of venom better in the New Mexico scorpions than in the Arizona scorpions, even though the two populations are the same species. In other words, it would only take about half as much New Mexico scorpion venom compared to the Arizona scorpion venom to create the same symptoms. Also, it would only require half as much anti-venom for the New Mexico scorpion compared to the Arizona scorpion to reverse these symptoms. These findings prove the need for antivenom in New Mexico that might someday save a child's life. So now I'm interested in toxicology and possibly venom research. This study showed an isolated population of bark scorpion being twice as potent as a large, diverse population of the same species, and antivenom which seems to reverse the venom's effects better even though it's more toxic. Why? Well, it's like everything in science. One answer leads to another question. But what can I say? I love science.